Okay guys, so this is going to be the first of my home videos. This is going to be my attempt to flip the classroom. So you guys are going to watch the lecture at home, do a couple of practice problems at home, and then you're going to come in and we're going to work together on some more practice problems together. So this video is maximum going to be about 10 minutes. So it also should hopefully reduce your homework. So if you watch the entire video and finish all of the practice that I ask you to finish in the video, then you'll be done and good to go. Okay, so this next unit is Unit 6. It's bonding, naming, and shape. So I'm going to get started. What I'm going to start with right now is actually a little bit of a review. So the first thing we're going to talk about are cations and anions. Well, we've already talked about these a little bit. Specifically, what I'm going to talk about right now is the difference between ions and atoms. So atoms are elements that have no charge. Okay. And the way that they have no charge, guys, is that their number of protons is the same as their number of electrons. So their number of protons, I'm going to write this as P plus, equals their number of electrons. All right, so while atoms have no charge, ions do have a charge. So specifically, they're elements with a charge. Okay. And therefore, their number of protons does not equal their number of electrons. Okay. Now, we talked about this really quickly in the last unit, and we looked at it in a couple of the multiple choice questions, but I'm going to talk about it in more depth right now, the difference between metals and nonmetals. Well, metals, if you think about them, remember they're on the left-hand side of your periodic table, okay, and your metals lose electrons, okay, and think about it. If you're losing electrons, that means you're going to have a positive charge. So they're going to become positively charged. Alrighty. Now, nonmetals tend to gain electrons, alright? And if they're gaining electrons, guys, that means they become negatively charged. Okay, so I threw around the word octet quite a bit in the last unit. And this comes back when we're talking about metals and nonmetals and gaining and losing electrons, because these elements, okay, when they're becoming ions, the reason why they become ions in the first place is because their ideal, okay, is to have 8 valence electrons. That is what the octet rule is that elements want 8 valence electrons. So all of this, guys, right now should be review. All right, let's keep going. A little bit more of review. A negative ion. Okay, if we're talking about a negative ion, remember this comes back to the title of this video right here, the title of this section. Okay, so your negatively charged ions are called anions. All right, so a negative ion is blank than the atom. So remember when we were talking about size, is it going to be larger or smaller? Okay, and what you should be thinking about is, since it's gained electrons, that means the size of the atom is going to be, or the ion, sorry, is going to be larger than that of the atom because it has gone and gained electrons. Okay? While a positive ion, remember, which is called a cation, is smaller than the atom. Okay, this should all be review. Finally, your Lewis dot diagram, that shows your number of valence electrons. Alrighty, so pause this video really quickly, okay, and complete the practice. What you're going to be doing is drawing the Lewis dot diagram. Remember, write the element name. So chlorine, for example, the number of valence electrons it has, okay, with using dots. So for example, I'll do the first one. Chlorine, you would write a Cl, okay, and you look at your periodic table and find out that it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, then you need to write whether it's going to gain or lose electrons, and then its charge. So pause this video right now and complete this. All right, now that you've completed that, which I will be checking, okay, we're going to talk about how you name cations, anions, and transition metals. Well, there's good news. Naming cations is really, 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 really easy. All you do is you take the name of the element, and you add the word either ion or cation. So I'm going to just say you add the word ion. Okay, so for example, if we're looking at calcium, you would just say the calcium ion. Okay, so for cations, it's pretty easy. You just say the calcium ion, you're done. It's very clear that you're talking about the cation and not the atom, which has no charge. Okay, anions is a tiny bit more tricky, not in no way hard though. Okay? So what you do, you write the name of the element, okay? But for the ending, you get rid of the INE at the end, okay? And you instead write at the end IDE. So you substitute IDE at the end. So for example, for chlorine, rather than writing CHLORINE, you get rid of the INE and you'd write chloride. And so I'd say this is the chloride ion. Okay, so still not too challenging, but it's a little bit different than with cations. Okay, the last one is with copper. Okay, so with copper, sorry, not just with copper, but with your transition metals. With transition metals, we had said in general your charge is going to be a +2 or a +1. However, most transition metals don't just have one charge, and we'll talk about it a little bit later in more detail, but they can have 2 or more charges. So they can be +2 or they can be +1. So in order to determine what charge we're talking about, what we do is we put the name of the cation, so the name of the element, and then right behind it, we put in parentheses the charge, okay? And we put the charge, we don't put a 1, a 2, a 3 in normal numbers. What we do is we put it in Roman numerals. Okay, so for example, here I would write copper. And since this is just a plus, we imply it's a +1 charge. So I would say copper, and I put a 1, Roman numeral 1, because it's a +1 charge, ion. Okay, so that lets me know what the charge of my transition metal is to try and make my life a little bit easier. Okay, so what you're going to do right now, okay, work on the practice. The only thing you have to be careful about is identifying which of these, okay, are going to be transition metals, because you have to have that specific putting in the Roman numeral behind the name. Okay? Otherwise, it's just going to follow these easy rules. The cation, okay, if it's not a transition metal, it's going to stay the same. You're just going to add the word ion. Anions, you just add the IDE. Okay? So pause this video right now and work on this practice. Alrighty guys, we've got one last thing we're going to be talking about, okay, and this is mostly me just going to be listing things for you. Okay, I'm going to be introducing polyatomic ions. Now polyatomic ions are composed of more than one atom. Now, they're still considered to be ions, okay? And what we do is we consider them as one whole, okay? So we consider them as one grouping altogether like we do with normal atoms. However, it's more than one atom together. So I'm going to list these for you, okay? In the end, you guys are responsible for memorizing them. And we're going to be working with these. You're going to have flashcards. We're going to do games with these to help you memorize them. But yes, you are responsible for all of these. Okay? So the first one we're going to be looking at is carbonate. Okay, so carbonate, the formula for carbonate is CO3. Okay, notice you've got more than one atom, but it's considered as one entity. Okay, not just carbon, not just oxygen, but as one whole, as CO3. And the charge of CO3 is 2-. Okay, the next one, hydrogen carbonate, you would think you just have a hydrogen, right? And then you have your carbonate, CO3. Now, since hydrogen has a +1 charge and CO3 has a 2- charge, yeah, it makes sense that HCO3 has just a -1 charge. Okay, nitrate is your next one. It's NO3 with a -1 charge. Okay. Notice the only difference between nitrate and nitrite is the number of oxygens. So nitrate has 3 oxygens, nitrite has 2. NO2 still has a -1 charge. Okay? Cyanide is CN with a minus charge, so it's considered one ion altogether, even though they're 2 different atoms. Okay? Hydroxide is OH minus. All right. Permanganate is kind of funky. It's MnO4 with a minus charge. Okay. Perchlorate, chlorate, and chlorite, and finally hypochlorite are all together. So you start off with ClO4 with a minus charge for perchlorate. Chlorate, you just take one oxygen, ClO3 minus. Okay. Chlorite, ClO2 minus, and hypo, meaning lacking, ClO minus. Okay. We're almost done. Sulfate, SO4, 2 minus. The only difference between 8 and ite is your number of oxygens. So sulfite has SO3. You just took away 1 oxygen, but it still has a 2- charge. Acetate, which is my favorite ion, you'll see why it's kind of funky. C2H3O2 minus. All right, don't let these severely overwhelm you guys. We're going to get a lot of practice with them. Okay, di meaning 2, chromate, so Cr2, and then it's O7 with a 2- charge. Okay, chromate, which is Cr04. 2-. Okay. Phosphate, phosphite, only difference is that they have a different number of oxygens. So PO4, 3- for phosphate, while phosphite is PO3, 3-. And the last one, which we're going to use a lot, is NH4 with a plus. Okay? So, what I would recommend doing right now, since you don't have any more practice, look over all of these polyatomic ions. Okay? We always consider them as one whole grouping. All right? We consider, for example, phosphate, PO4, as one whole. We don't break them up into the P and the O. It's phosphate, PO4. Okay? So look at those. If you want more review of the notes that you just listened to for the last 14 minutes, I would recommend rewatching this. Okay? So that's all I'm going over for this first lecture. What we'll do in class tomorrow is go over the ion charge review. We'll go over your answers for the practice, and then we'll get more review with the polyatomic ions. Okay. So what I would recommend is you guys go over this one more time, write down any questions you might have, and we'll go over this in class. Okay. See you guys tomorrow.